Hello friends, welcome once again to Esomnofo Online Maths. In this video, I'm going to prove to you that a perpendicular drawn from the center of a circle to a chord bisects the chord. To bisect means that it divides the chord into two equal parts. Do not forget that this video is proudly powered by Your Lesson app. Catch me on their TikTok page at Your Lesson app. Go to Play Store, download and subscribe to their app so that you can enjoy my math videos. So we have that a perpendicular drawn from the center of a circle to a chord bisects the chord. Let us draw a circle. This is a circle we have before us, and let's assume that this is a chord. If this is a chord, here is the center of the circle. So this theorem is saying that any line drawn from the center to the chord, a perpendicular, so a perpendicular means it forms an angle of 90 degrees. So a perpendicular drawn from the center of the circle to the chord bisects the chord. So supposing here is A and here is M, while here is B, we want to prove that line AM must be equal to MB. That is what you want to prove, that these two distances from here to the center and from M to B are equal, because the theorem says that a perpendicular drawn from the center of a circle to a chord bisects the chord. Then I want you also to note that if you have a circle like this with center O, for instance, the distance from the center to any part on the circumference remains the same. We call it the radius. So this is distance from the center to the circumference, which can be called the radius. So here is the radius. Now, you need to know that OM, line OA, is equal to OB. So line OA is equal to OB. Reason is that both of them are radii. Okay, so the line OA is equal to line OB. They are both radii. If that is the case, you also need to know that OM is common. Line OM is common to both triangle AOM and triangle OBM. Right, both triangles share this line OM because it's common to both of them. So if that is the case, since OM is common to both of them, and also you notice again that this angle is 90 degrees and here is also 90 degrees, they share the same angle. That means angle OMA is equal to angle OMB, which is 90 degrees common, which is a right angle also. So if these two triangles on both sides, one at the left and one at the right, have common radii, they have common sides, hypotenuse, which are equal, they also have a common side here, this length, and they share the same angle, 90 degrees. That is to tell us that both triangles are congruent. Therefore, you can conclude that triangle OAM is congruent to triangle OBM. Both of them are congruent. And the reason behind the congruency is right angle, hypotenuse, and side. This is one of the reasons. Okay, because before you say that two triangles are congruent, you must have a reason for that. The right angle is this angle 90 degrees. The radius is a hypotenuse of this triangle. So that's why right angle, hypotenuse, and the side is this common side between them. So if these two triangles are congruent, it follows that AM must be equal to MB, since they are the third side of the triangle. If they are congruent, it means that AM is equal to MB. Proved, and that is what we want to prove in this particular lesson. You can as well use Pythagoras theorem to prove this, and you will get the same answer. Do not forget that this video is proudly powered by Your Lesson app. Catch me on their TikTok page at Your Lesson app. Go to Play Store, download and subscribe to their app so that you can enjoy my math videos. Thank you for viewing and may God bless you. Bye bye.